So we're doing 8.3b now. There's no quiz for whenever we have A. We have the quiz when it shows up. So we have to, for this section, we do have a quiz and an additional practice. So just so you're aware of that. Okay. We're expected to be able to understand these different forms and work with them. Okay. I feel like we should. Yeah, let's not do that. Okay. So vertex. This is called the vertex form. Why? Yeah. Yeah, because what can we see just looking at it? The vertex is literally sitting right there. It would be H, comma, K. Right? Let's go ahead and close Chromebooks. Y-intercept is a little trickier on this one, especially if I just have letters. But what is the trick to finding the y-intercept? Yeah. X equals 0. We want to know when is x equals 0, and then we can just find it from there. Okay. Sometimes it's just sitting there and we can see it, but not on this one. And people got confused because they're like, oh, it's this last thing, but it's not. Okay. It could be, but it's not in most cases. Axis symmetry means x equals h. And I hope that we understand that this is a line that literally cuts it in half. If I did y equals a number, it'd be a line, x equals a number. Okay. X-intercept. We haven't talked about this before, but how can I find the x-intercept? Yeah. Okay, so we could visually see it if we threw this into Desmos. Y equals 0. Okay, so we want to just plug y equals 0 in there. And then for max and min, we're either going to have one or the other. Let's say that our graph, I need more space here. When are we going to have a max point? Yeah. When it's a sad face, okay, we'll have a max. Where is that max? At the vertex. That right there would be our max. When would we have a min? When we have a happy face, and where would our min be? Can you have both a max and a min? No. When you get to calculus, we'll talk about things called relative maxes, meaning that if I stop the graph right here, then I would say like, oh, this is a min, and that's a min, okay, or the lowest point. But for this purposes, we're just going to say the max or the min. We really wouldn't have both. Yeah. Then we usually don't talk about maxes and mins in those situations. Okay. Next one, standard form. Okay. Our vertex. What is our vertex here? A lot of people came up to me yesterday and go, I don't know how to find vertex. And I said what to them? I said one thing. Yes, I said negative b over 2a, comma, and then I said find. Y-intercept. We just plug in x equals 0. And what's nice about this one, when I plug in 0 for x, it makes this 0, makes this 0, and what's left over? C. I would almost prefer you just to know plug in 0 for x than to think it's C, because then that's when people start making mistakes and just start going, whatever's at the end there is our y-intercept, but it's not always the case. X equals negative b over 2a would be our axis of symmetry, whatever that number is there. We wouldn't recalculate it. How would we find the x-intercept? We would want to find y equals 0. And then these are going to be the same, right? The same as before, so we won't even put those there. Okay, looking down here. Factored form means that it's what? Factored. Okay. So yesterday people were going, how do you do factored form? I said, just factor it. Now, you have to have it in what form to factor it? Which of these two is the one that I can factor? It's got to be in standard form in order to factor it. Okay. I don't know how to factor from here. The weird thing is this feels almost like it's factored form, but it's not, right? So factored form just means factor it. So bad thing is to find vertex, I have to do what? Unfactor. I have to put it in standard form. And then once it's in standard form, I got to use negative b over 2a. Most of these problems are about finding the what? The vertex. The vertex is kind of like the most important point in these. So most of the time it's like if you can find the vertex, everything else kind of falls into place. Y-intercept, we're going to go ahead and just plug in, to find it, we're going to plug in x equals 0. Okay, there's no trick to that. Axis of symmetry is going to be x equals whatever we find from the vertex. So this is the only one where x-intercept has a trick. Give me two numbers. 2 and 5. The x-intercept is when y equals 0, right? So y equals 0. If I can make one of these 0, then what would happen to the other one?
Excuse the interruption. Would you please send Bryce Freeman to the office for a moment? Thank you.
So what would do you want to wait until after notes, or you want to just fly down there? Okay. So what would happen if I made this parenthesis equal to 0? Okay. So what I mean by that is if I were able to make this, let me clarify that. If I make this parenthesis 0, then what would be true about this whole thing?
0.
It equals 0. And if I could make this one equal to 0, then we wouldn't care about that one. As long as I can make one of them 0. What value of x is going to make this equal to 0? The first one. No. -2. -2 plus 2 is 0. So that's going to make it y equals 0. So the answer, my x-intercept is -2 and -5. We got to make that equal to 0, and that's going to, in turn, make the whole thing 0. Okay, we'll see that again. And then max and the min is the same as before. Okay? So that's kind of an outline. In my brain, I debated whether we should do problems with numbers first because I think it kind of helps. But what form do we have this in? Standard. Okay, so we got to be able to identify the form. How do I find vertex? -b over 2a. Now, finding the vertex to me is like off to the side doing some math. So -b over 2a. So -9 made it +9 over 2 times 2, which is 4. 9 divided by 4 is, 1 point what? 1.25? Is that right? 2.25. Is that right?
Yeah.
Okay. So that's my x value of my vertex. Now I have to find my y value of my vertex by plugging that back into this. So I go over here to my calculator and I just say 2 parenthesis 2.25 parenthesis squared minus 9 parenthesis 2.25 minus 35. We get this ugly thing. So my vertex is 2.25 comma -45.125. Now, something I want to point out. I know that we can throw this in the calculator and find all kinds of things. we're expected to be able to do it without the calculator. Am I going to take it away from you? No. But when you go and you're like, I'm just going to do everything in Desmos, and you don't learn it this way, that you're kind of setting yourself up for some trouble. Just put my 2 cents out there. Okay. So when you do the homework, I would advise not just throwing it in the calculator. Okay. Y-intercept is when x equals 0. Yeah.
So when we get a geometry, are we not going to be able to use a calculator?
You'll be able to use a calculator for the rest of your career.
Because someone in the when I went to that meeting accuracy, it's saying something about not being able to use a calculator.
So Walters and I have a different philosophy on that because you get to use it on the state test. I let you use it all the time. She knows for this stuff, it doesn't I shouldn't probably let you use it, but I let you use it because it's never going to be taken from you from the state test. So you could get a teacher next year whose philosophy is hey, you shouldn't have a calculator on this part. It's up to the teacher. So the teacher might have no calculator part. I think in calculus, the AP exam, there's a non-calculator part. So yeah, it's not called calculator. It's called calculus. Okay. Y-intercept means plug 0 in for x. Can we do that in our head? Well, that would become 0. That would become 0. So what's the answer? Negative 35. Axis of symmetry is just whatever that first value is. And hopefully we understand that that is actually a line cutting through. X-intercept. We don't know how to find this. I wonder if I ask you to do it on. Okay, so we'll come back to that. I'm not sure how I asked you to do that. And then max or min. So do we have a max or a min here?
No.
Well, it's a yes. It's a min or a max. We have a minimum. How do we know that? The A is positive, which means I like the terminology we use, which means it's smiling. So that means we don't have a max. There isn't one. I'm not writing 0 there because 0 could be a max. I'm saying there isn't one. And what would our min be? So how low? So here's something we need to know. You can answer this a couple ways. We could just write the vertex down, but I want you to understand that our min, our lowest value, our lowest output is negative 45.125 at what location? At 2.25. So just so we're clear, this is the min or the smallest outcome. Okay, this is the min. This is the smallest outcome. And this is when it happens. So it depends on how I'm asking the question. If I say, when is it at its lowest? You'd say 2.25. If I said, what is its lowest? You would say negative 45.125. If it just said min, you might answer this, or it might say, give it to me as an ordered pair. Okay. We're going to skip the x-intercept for now, and we might come back to it. Okay. What form is this? Vertex. Could somebody, and the reason it's vertex, because the vertex is just sitting there. What's our vertex? -5, -8. And someone asked a couple days ago, why is that -5?
Because
when you're with your x, you do the opposite. Okay. Got that? Okay. Y-intercept. What's that?
What if you're friends with your ex?
Yeah. Okay. Then the analogy doesn't work. you could say, when I'm with my ex, I do the opposite, except in real life because I'm really friends with my ex, and therefore I wouldn't do it. Is that better? Does that help? It's just a fun little way to remember it. I don't think I've ever driven in the car with my ex and she said turn left and I turned right. Okay. Though I did have a friend once who, we were driving and I said, you got to turn right. I go, turn right up here. He was so like, he couldn't handle people giving him, like telling him what to do. He'd be like, I can't turn right now. A friend of mine. It really was, he just didn't like me telling him what to do.
Exactly. When your parents ask you to do when you're going to do the dishes, but your mom asks you to do them.
Yes. Yeah. Right. It makes you a little, but this is a little much, right? So me being ornery, being kind of a punk, I would give him directions for the rest of the time. And he had to figure out how to like get there without going the way we're supposed to. Anyways, okay. The same friend, you know.
Turn right here.
Yeah, exactly. And he'd be like, and he'd just go around.
Like they're actively turning, you're like, you gotta turn. I would like stop the car and just turn right.
Or you can just like make you not talk.
How's that?
Just take it down.
Oh.
Okay. Y-intercept means let's plug in what for X. Y-intercept's another way of just saying plug in 0 for X. Some of us, our gut would say it's -8, but that's wrong. We got to be careful. I like doing math over here. -3 times 0 plus 5 squared minus 8. I would totally just type that in the calculator. And I get -83. Axis symmetry, X equals -5. I just typed in the calculator, but 5 squared is 25 times that is negative. Okay. X-intercept, we'll come back to this. Does it have a max or a min? It has a max, so we're going to say that there isn't one there. Or we could say NA, not applicable. So our max is, depending on how they ask it, what is our highest value? I asked you, what's your highest value on this? What would you say? -8. Our highest value is -8 at.
Technically, isn't it -5?
No, -5 is where it's at. -8 is how high is it? And I know some of you are like, how can a negative be the highest point?
Oh wait, is it let me check the notes.
How can a negative be a highest point?
Because it's the lowest point. We're doing the math.
It's relative, right? So our graph, if I were to graph this thing, our graph is like this. Okay, our highest point is a negative. If I'm saying what's the hottest it's ever been in Antarctica, it might be a negative answer. Okay. Going on to the next one. Vertex. How do we, what form is this in? Vectored. So all of them have a reason why we like it. Okay. This one has one reason that we like it. Anyone know? I can't, the vertex. I can look at this and I can answer one of these questions without doing any math, except in my head. Brody? Okay. So which of these can I answer without doing any work?
The y-intercept, you plug in 0 for X.
Okay. What?
The math would be -42.
I love it. So he says I can find that intercept real easy by plugging in 0. There's one other one that we can find easily. Yeah, Brody. Say again. What is our x-intercept? That's correct. -7 and +6, because that's going to make this equal to 0. I don't care what this is, making the whole thing equal to 0. That's the form that that's for. Say it again. So let me explain it better, because I did go kind of quick with that. X-intercept means that y equals 0. So if I go over here and I say 0 equals x plus 7, x minus 6, that would be making y equal to 0. What value would make this first parenthesis 0? -7. So if I plug in -7,
Why do you have to make it 0?
because that's what y or x-intercept means, is when does y equal 0. So if I plug in -7 in there, I get -7 plus 7, and then I get -7 minus 6. I don't care what's happening over here, because once I get one of these to equal 0, then it equals 0, right? And then what would the other value be that also would work? +6, for the same exact reason.
So is it max?
Does this have a max? So that's why we have factored form, is to find this answer out, and then even that one is easy. What form do we need to turn it into to find our vertex? We got to turn it into standard, right? Almost always we're going to turn it into the standard to find our vertex. So that means I got to do x plus 7 times x minus 6. I noticed I was working with someone the other day, and they were getting really fast at these, because they were able to combine the middle term, okay, which was, I thought, was pretty awesome. Okay, so there's my standard form. How do I find my vertex? -b over 2a. -1/2 is the first part of my vertex. And then I got to find the other part. I don't know about you, but I kind of like working with this in my calculator even, because I can just go parenthesis -0.5 plus 7 parenthesis x, or no, -0.5 minus 6. I kind of like that. Gives me -42.25. Didn't give myself a lot of room there. Once I have that, I can pretty much answer all the rest of the questions. Axis of symmetry, x equals -1/2. Does it have a max or a min? I think we like looking at this form. Does it have a max or a min? My A is positive. That means that it is smiling. That means I have a min. So there is no max.
So is it 42.25?
Yep, that's how low it gets at -1/2. Again, they may ask that as an ordered pair. You okay? Did I hear a question? Okay. So, word problems. Word problems, we're really going to be using Desmos to kind of explain the graph. Okay, so that is part of the expectation with that. And a lot of times we get really confused on what does. That's definitely a point. That was you too, Don, wasn't it?
No, it wasn't.
It was
What
clip.
do you mean, Brady?
Oh, and now you're lying to me?
Now you're lying.
How many points is lying to a teacher?
I'm not lying.
You're not lying?
That's 4. No, it's a 1.
What rhymes with lying?
There it is. Right there.
Attention. That's
Clearly.
Literally what happened.
Stating you're lying, that's a point.
Everybody's lying, that's the point.
All right, so here's my graph. I don't know how how good we are at making our graphs kind of fit. So if they don't fit, I can always go to my home button to reset if I got a weird graph. You should hopefully be able to kind of figure out X and Y. So my X and Y here, if I wanted to kind of clean this up, would be, I don't know, all I need on this is, I think, from -5 to +5 for my X, and then maybe -5 all the way up to 20, and I could make the graph a little bit cleaner, but this one's not terrible, okay? So let me read the question, and then I want to talk about different points about what on this graph, okay? Antoni, is that his name?
Wait, so how are you supposed to do this one without a calculator?
You wouldn't.
You should give them
What's that?
this water would give
Yeah. I mean, maybe, yeah. So she definitely gives him a calculator on some parts. Okay. And Tony stands on a balcony and throws a ball to his dog, who is at ground level. The ball's height in meters after the above the ground, seconds after Antony threw it, is modeled by this red graph here.
That's a weird way to spell that.
I know. Am I reading that right, you think? Antony? Antoine. Excuse me. Okay. So what's happening in this problem? Guy's throwing a ball to his dog. Where is the guy?
In his house.
In his house, right? He wakes up, he's tired, he doesn't want to go outside, so he goes to the balcony. Where are balconies?
On the back.
He's kind of up in the air, right? Where's the dog? On the ground. Okay. So this is what the ball does over time. Okay. So tell me about different points that are on here that jump out at you the vertex. Okay. Vertex is important. Now I'll tell you that Desmos is awesome because you use this calculator. It takes me about 2 minutes to find the vertex with this calculator. Okay. This one, you just click on it. What is that point mean? Actually, let's find the other points first, and then we'll ask that question. We got that point. What other point do you think is a point of interest?
The other one that's a dot.
The other one, this one right here, that's interest, and they actually created another dot for us. What other dot do you think? The x-intercept. Why do I not care about this one?
Because that's when he's going to upstairs to the
Okay, kind of. I mean, that's a good way of pointing it. We're talking about x's time here. Luke, will you go ahead and close your Chromebook, please? X's time. What is this what is this saying? Negative. Before we started paying attention, right? So in a sense, this negative part doesn't really mean anything. I like your thought, right? If he's downstairs and he's walking up, this is before he gets up there, but it doesn't mean anything. Okay. What does this first point right here mean?
No.
It is the y-intercept, okay? So we have two ways of saying things. We have the math term, but in relation to the problem, we're talking about a guy throwing a ball, right? I'm on my phone and I'm like, hey, there's this guy throwing a ball off his balcony and his dog is chasing it. I'm talking to my wife and she says,
Why are you asking?
and she asks a question and I say, oh, it's the y-intercept. She's gonna be like, no, let's focus in the real world. What is this problem? Yeah, that's the balcony. Okay, that's where he is on the balcony. What does the 0 mean?
Is it feet or inches?
The x is our time, and the y is,
At 0 seconds, it's still how high up there?
okay, yeah, how high? And this is meters, right? So at 0 seconds, he hasn't what? He hasn't thrown it. That's telling us how high it is off the balcony. That's where it starts.
How do we know it's
When he threw it, did he throw it like this down to the dog, or did he kind of like throw it up a little bit? He threw it up a little bit. How do we know?
because it went up?
Because it literally went up. What is this point right here?
It's higher than
The max. Now, this is where I keep going at the one thing means this and the one thing means that. What does the 18 mean?
how high up.
That's how high it was off the ground
No, that's 1 second.
at 1 second. Do you see how that vertex, that max, is I say, oh, it got all the way up to 18 after a second. And then finally this point, what's that?
When it hits the ground.
When it hits the ground. So that assumes what? Did the dog catch it?
No.
No, that's assuming if the dog didn't catch it. Okay, if the dog caught it, we could draw a picture of a dog. Would he catch it there?
No.
No, where would a dog catch it?
Probably like at like. It depends on how tall the dog is.
Depends on how tall the dog is. Would he catch it up here? No, he would catch it. The dog would catch it somewhere around here, right? Don't you love watching those videos where they throw the ball and the dog goes for it and completely misses it? You ever see this?
I love the videos where it hits it over the face.
Oh
I
yeah.
like the videos where
All right. How high is the balcony? Yeah. 16 meters. So we know that because, boom, that's where he threw it from. What is the max height of the ball? 18 meters. Notice that it doesn't ask when or anything about that, right? So if you said 1 in this answer, I would mark it wrong, okay? At what time does the ball hit the ground? 4 seconds. Okay, so do you see how you have to be able to read these special ordered pairs? Okay, if I said, that the dog leaped up and caught it, we could then start talking about, okay, how high could it leap up and where would it catch it? Okay, and so forth. Okay, so we graph it and then we have to understand those different points. So if I ask you for the x-intercept of the ones that we didn't do, I feel like this is a Desmos question, okay? In Algebra 2, we will expect you to be able to find this without a calculator, but we're not there yet except for the 1. So if I ask you for the x-intercepts and we graph it, they're just sitting right here. There are those two values. So my x-intercept, I went back to the first page. For this one, would be negative 2.5 and 7. The only way I could find it without a calculator would be to do what to this problem? What form do we need to have it in order to find it? Which form? Nope. Vertex. Nope, not vertex. Everyone's got me there. Factored. It's got to be in factored form. We can actually see that. If I wanted to do this one, okay, I could just type this in just the way it is. And we could find it. Now, this is off the thing. Now, so this is interesting. What are my x-intercepts here? Looking at this graph, what are my x-intercepts? None. It never hits it. So for this one here, we're going to actually say none. Okay, because it doesn't hit it. And we're able to do this one because it was in factored form. Say again?
The last one? I thought you said that one was negative 2.5.
No, that was the one.
I did this one. And then I turned to the page and I did this one. And there's none. So here's how they kind of, Brody? No. X squareds don't do that. Yes, in Algebra 2. Okay. So here's kind of how they kind of make it. So the state test goes, I expect you to be able to do this without a calculator. So they ask questions that you can't do with a calculator. For example, like down here, if I tell you the vertex and some points, you can't just type this in and get the other information. Okay. So that's where we got to be kind of careful. I agree that in this one we can. Okay. But on the other ones, we kind of want to, and honestly, when I look at this, I can answer this question without a calculator probably 100 times faster than you could with a calculator. Okay? Because the vertex is just sitting right there. Yeah.
So you know how, like when when you put it where x equals 4, there's like a continuous line. Is there a way to like have boundaries? Like it stops at certain numbers?
Yes. And I'm glad you asked. I'm going to answer that question, and I'm going to say one other thing too. We said on this one here that our asymptote, not our asymptote, our axis symmetry was x equals -5. Okay. So that literally, when I drew that, that's literally the line cutting in half. You want to cut that line? You don't want it to go on forever?
Yeah.
Why?
Well, I'm just saying, like, because I know someone told me that, like, at the end of the year, we're gonna like draw the thing with it.
Yeah.
And I didn't know if like.
I'll teach you that then. But what we do is then I think we go space, and then you say like for x is less than 0. I think, or no, maybe I have to put a comma here.
It doesn't matter. I just-
Mr.
Okay.
McConnell, isn't that thing at the end of the year?
Ye-
Isn't it like when we had to turn it in?
Yeah.
The first person to turn it in, you give us a couple days or like a week after that, whatever it is. I thought there was something like that.
I don't remember how to cut them. I have to look that back up. But go ahead. What was your question, Tom?
Oh, mine?
Yeah.